Hey guys, good afternoon. Am I audible? Guys, just give me quick confirmation so we can start. All right. So let's get started then. Hey guys, welcome back to the series of this deep learning for computer vision and NLP. Okay, computer vision NLP. So why I'm saying this now, computer vision NLP is this week we will be specially focusing on the computer vision NLP, generative AI, deep fake, right? On this kind of topics. So we started initially with understanding what is artificial intelligence, like what are the types of the artificial intelligence, how AI has become a new services, right? Looking at the data, it has generating like around 175 zettabytes of data is generated every day, out of which 80% of the data is completely unstructured. It means it creating the text, videos, and images. And in order to handle that, deep learning is now gaining the popularity. So we try understanding. Then first we started with what is the difference between deep learning, machine learning, artificial intelligence, how they are playing role, whether they are interconnected or not. And then we started understanding the basics right from the beginning of the machine learning. So how the machine learning is, what are the different approaches in the machine learning, right? Supervised, unsupervised learning. Then what are the popular algorithms? So how can I build up algorithms? We started even having a hands-on with our understanding that how we can build a classification model or regression model. Then we were able to discuss the amazing use case for the detecting the sleep disorder, right? So we were able to successfully run it. We went through the code and everything. Then we started with the deep learning, like what is deep learning? What are the different approaches in the deep learning? And then we talked about, we started initially from the single artificial neural network. Then we talked about the single neuron, how back in the history all these things started, right? So single neuron to perceptron, then perceptron to multi-layer perceptron, then who invented this back propagation, what are the purpose of this back propagation, entire neural network architecture we were able to understand, like what is feed forward network, what is forward propagation, how the weights are getting calculated, what is gradient descent, what is activation function, loss function, what is it doing in the background, how the weights are getting calculated. Till all this understanding, it was really amazing journey. And once I think this is really superb that we have learned and come up to this ladder. Now we are trying to approach to a upper ladder where we'll be specially focusing on to the more techniques of the deep learning. In the deep learning, we'll specially trying to handle the data in terms of the unstructured data, where we'll be dealing with the images, videos, and how we can make a amazing use case, or how we can solve the business use case regarding this deep learning and using the technique of the deep learning. So in last lecture, we were able to discuss that how we can create our own neural network architecture, and we were able to make a code walkthrough where we have created a very simple neural network consisted of the three layers: input layer, hidden layer, and the output layer. And we were able to use the business case of the bank customers, right? So where the bank customers are leaving, whether the bank customers will leave the bank or not, that was the prediction we were trying to achieve. So agenda for today is we'll be starting with something very interesting, like how to deal with the multi-class classification using the artificial neural network. So initially, I will start with the agenda for the artificial neural network with the multi-class classification. I will make a code walkthrough. Then we will start with a really interesting topic of the NLP, which is chatbot. So today I will show you how to create a simple chatbot using the Google Dialogflow. Before we jump into it, we'll try to understand how the chatbots got into the picture, why they are gaining the popularity, and how, what are the different platforms which are available in order to discuss or create the chatbots. So end of the day, we will be able to create a simple chatbot on the basis of the different interaction, how this chatbot will react to us, and how can we create a simple chatbot which will take care of the at least FAQs. Let's say we currently ask question by the customers, how it will be able to deal with the customers, and whether it will be able to give the satisfactory right answer to the customer. So that's the agenda for today. And going forward, we'll try to focus on the convolution neural network. What is the convolution neural network? How the images are getting classified? How the features are excited? And then we'll probably try to focus on the transfer learning and the recurrent neural network. So what is transfer learning? How can you use the transfer learning, whether it is a popular approach what is the entire understanding behind the transfer learning. Once we complete the transfer learning, we'll be switching to the recurrent neural network, and on the last day, maybe we'll be dedicating our time for the generative AI. What is this chat GPT is? What are these LLM models are? We try to have a certain understanding about it. So okay, guys, then I think we have discussed pretty much, and then everyone is now clear with the topics. So what all the topics we are going to cover this week and what we have discussed until now. So I'm sure that you guys are now excited, right? So just quickly ping me your responses that you guys are excited. So we are going to create a new chatbot. And before that, let's have a code walkthrough, right? Just have a code walkthrough. I will go to Google Colab. I will try to share a Google Colab link with you guys. And maybe in the Google Colab, we'll try to create one artificial neural network. All right. Let me share my Google Colab with you guys. Just a moment. All right, guys, everyone able to see my Colab? Just quickly ping me so we can start the code walkthrough. All right. All right, guys, let's get started then. So now I will be closing the chat box. Maybe I try to focus on the code first. So this is a Colab link, guys. I have already created a code, and maybe line by line we'll try to go through the code and try to understand how to create a multi-class classification neural network. So let's call this neural network. Let's give us a name because this neural network will be created by us. We are the architecture for this neural network. So maybe we can call this neural network, because whenever people they come up with the different neural network architecture, they tend to give a name of theirs as a neural network, what it's to be called by afterward. So let's call this as, give a fancy name, let's say Vikas and its class. So VIX. Let's call this neural network as a VIX, and let's see how this VIX perform in terms of the multi-class classification. So just to get started, first what we'll do is we'll try to start with the importing the necessary libraries. So again, I told you in the last session that we'll be using the TensorFlow in the background. So first library which we'll import is a TensorFlow, and then from TensorFlow we'll be calling the Keras library. So Keras is a high-level overview, high-level API using which we'll be able to create a sequential, using the function sequential, we'll be able to call a model or create a model, right? So for this call then Keras, and from Keras again we'll be calling the sequential, which is the model which we'll be using to create our architecture. And then from the layers, we'll be using dense layer and the flatten layers. So dense layer, again, the flatten layer we already discussed, just to tell you that this kind of the layers we'll be using to define our neural network, right? So flatten layer most probably for the input layer, output layer, and dense layer for the hidden layer. Let me run this code. All right. So let's go to next part then. Once I am able to import all my libraries, what we'll do is we'll try to load a data set. Now here I am going to use the data set which is already inbuilt in the Keras library, okay, Keras API. So this data set is called as Amnis data set, and this data set consists of the 10,000 images, and all these images will be something like this one. So all these images will be containing numbers on it, right from number 1 to 10, okay. And our job is to identify whatever picture we will provide to this neural network, it should be able to identify it and correctly, and it should be able to identify which number or which digit it is having in the picture, and it should give us the correct classification accordingly, right? So that is the use case. So for that purpose, let's again prepare our data set xtrain, ytrain, xtest, and ytest using the keras.dataset.amnis.load data. So this will load us a data, internal data set for the Amnis database, and then try and check the shape of our data. So xtest.shape will give us the count that we have a 10,000 images, and the dimension of these images is 28 by 28. So we understand, right, what is 28 by 28? So this image will have a dimension of 28 pixels. Sorry. 28 by 28. Again, it is a color image. Maybe it's multiplied by 3 then, right? So this will be the pixel values for it. So we already understood that pixel values lie from 0 to 255. In between, there will be any value which could be the combination of present in this case, right? So this kind of matrix it will generate in the background in the 3 layers of RGB, right? RGB, red, green, and blue, and with the varying intensity of the pixel between 0 to 225. Whenever we talk about the color intensity, it will be having the minimum value as 0 to 255, and within that intensity only all the values will be lying, and the images will be created using the different pixel intensity with the combination of this RGB, and then it will be give us a color image. Okay. We understood now that we can load this data set, and we have checked our shape of the data set, which is a 10,000 images having the dimension of 28 by 28. And so let's try understand that what is there in the Y-train. Y-train consists of an array which will be giving us the number, whether this number is between 0 to 10, right? 0, 1, 2, 3, 5, 10. So Y-train, again an array which will containing the numbers. So this is the number which will be providing the target column, right? This is the target and this is the data set. Let's say features in this case. So again, try to print one of the image. Let's take one image and try to print how it will look like. So I have taken a training data set, and out of that I have taken a second index. Maybe you can check another picture also. So this is one, right? Let's check another image also. Okay, guys, please repeat. So, ma'am, can you just please tell me what are the points you need to understand, or should I start even again from the beginning? It will be nice if you can give me a pointers that which point you want me to repeat, so I can again go ahead and start. $10,028 by 28. Okay. So, guys, shape of our data set is 10,000 images, right? How many images I have? 10,000. And then what is the dimension is 28 by 28. Let's understand what I'm trying to say here by using this. Whenever I am giving any picture, let's say in this case, I am giving the images, right? This number of images which I am giving are 10,000. So complete 10,000 images I am feeding to my ANN. Okay. So this is what it says, 10,000. The number of images which I will be giving to the model, right? This model, and this model, in fact, it is a neural network. I will again discuss what are the layers we are trying to check and everything. And then, like, let's understand the output is like 10 nodes. There will be 10 nodes, and this will be able to give us the, are they inbuilt? Yes, yes. These images, this data set is inbuilt data set, which comes already with this package, right? So this Keras is already having this data set available with it. So we are just trying to download that data set into the current session, right? So because collecting again this kind of 10,000 images will be a tedious task, and which will be difficult if there is any data set which is predefined or already available. So we can use it. What is the basic idea behind taking this data set is that if I am trying to provide a more and more number of images, maybe it is the probability that my model will be able to understand it betterly. It will try to figure out the pattern, then the accuracy which I am trying to achieve will be very high. So the model, the issue with the deep learning models is it requires a huge data set, because if you even try to provide a simple data, let's say 50 or 100 images, maybe it is possible that it will not be able to learn that. Okay, it will not be able to learn from the 100 images. It is also possible. So it is always better to give more and more images, whatever images we have. In fact, if there are not in reality, sometimes it is possible that we are not having such a huge data set when we are trying to solve our data business case. At that time, it is also possible that we try to create a data augmentation. Let me write everything from the beginning. Data augmentation. This is the concept which is used in the deep learning to create the extra data. Create the extra data from the existing data set. So what it does is this data augmentation technique, using this data augmentation technique, let's say I have 1,000 images. Maybe it will try to create out of these 1,000 images, it will try to tilt these images, maybe somewhat leftward, somewhat rightward, or somewhat upward or somewhat downward, right? Let's say this is the image and this image contains the number 8. So what it will do is, rather than taking just 8 as the single image, it will try to create the image in this way. Let's say I'm trying to tilt it upward. So again, it will try to change somewhat direction of the picture. So maybe from here to here, from here, maybe, or maybe from here, or maybe here. So this kind of adjustment it will be doing in the backend, and then it try to give us a duplicate copies. It is divided into training and test data, or complete data is taken. Okay. So it is complete. Try to understand that we are taking a complete data set. This keras.dataset.mnist.load. It is an entire data set, but since I need the split, so that's why I'm trying to take this as an xtrain, ytrain, xtest, ytest. This is how my model will be taking. So I am loading the complete data set. Okay. And then we understood what are the 10,000 number. Then 28 is 28 by 28 means the pixel intensity or the dimension of my image, which is currently present, is 28 by 28. I told you guys that the image intensity lies between 0 to 255. Okay. And we can have a even high resolution image. Then by xtest.shape is 10,000. Okay. So it's trying to say that I am taken a 10,000 images, and out of that, it is showing the shape as 28 by 28. I have not splitted it, right? For that purpose, just for the understanding purpose, let's take this, imagine this one, that out of this 10,000 image, it will try to again split further. Okay. So whenever we'll try to do, but just for the initial purpose, we're trying to load entire data set. Or maybe then we'll try to split that using the split percentage, let's say 80-20 or 70-20 when I compile the model. Okay. So that's a good question. Why it is showing 10,000? Just for the purpose, we are trying to show what are the shape. That's why it is showing. First, it is trying to completely load the entire data set, and maybe there are more images, more than 10,000 may be possible. I have not checked what is the total data set. So out of that, minimum 10,000 images are given to the test data set, and maybe it will try to split it again at the later stage. So just for the understanding, try and understand that we are taking this much images of this shape, and then we try to train the model. Okay, I guess this answers the question. We'll try to move further. So we understood what lies in the xtest. Xtest will be containing the images of 28 by 28, maybe let's say 10,000 images. And then ytrain contains the array which gives us the numbers between 0 to 10. Okay. So we can try to plot and see how the images are looking like. So this way we were able to see what are the images and how they are looking, right? So our first number, it is showing 0 this way. We try to see it, right? So then we try to see whatever the data set is there. We always do a standard scaling, right? Remember, if you could remember, in machine learning also, we will able to scale them, right? Using the standard scaler or using the normalization. For the same purpose, we are trying to again scale the data by dividing, since the pixel intensity lies between 0 to 25. So we're trying to again divide them by 255, sorry, 0 to 255, and then this way I'm trying to scale them. This is just try understand this as a scaling process of the scaling, where I'm trying to reduce the magnitudes. If there is a high magnitude, maybe at that time my model may be getting overfitted, or maybe it is biased, so I have to again use the regulation sort of thing. So in order to avoid that, in the first stage only, I'm trying to do a scaling. So once I scale them, this is how the xtrain will look like. it will be giving you the numbers in this way. These are all the matrices which are stored, right? So now coming back to the model part. So this is super important, guys. Try and focus this one. So what we are going to do is the same way we created a binary class classification. We are again trying to create the model. Now, first I will call a sequential method. Okay, model equal to sequential. This is the function using which we're trying to create this architecture. Let's say Wix architecture, Wix, the class and the class. We together combine, we're trying to create this one, right? So what we are going to do over here is, first we'll try to add the layers. So first, what I will do, I'll create a, let's try and guess that we already discussed much about the neural network. So, and I have already guys told you that what business case we are trying to solve. So we are going to take an image and this neural network should be able to tell me whether this image belongs to what particular number or what particular number is written on this image, right? So again, first, whenever we trying to decide the architecture, we need to decide the input layer, the hidden layer, right? And the output layer. So based on our learning in the past weeks, right? So can just anyone quickly tell me that how many nodes should I take in the, how many nodes should we take in the input? The code is already there, but you have to just tell me also the logic that how many input layer you will be taking and how many output layers you guys will be taking and what will be the reason for that. 28 as an input layer or hidden layers. First, we'll try to answer the input layer. So obviously input layer will be 1, number of layers will be 1, right? Then we have to decide the nodes, number of nodes, right? So this is the question that how many nodes we'll be taking. Ujula ma'am is saying that we can take 28. Can we add an extra hidden dense layer with 64 nodes, sir? That we'll try to answer when we're going into the detail. So first try to fix our architecture, that what we are trying to propose here in the architecture. So Anita is saying that 1000. So are we going to take 1000 nodes? And can you just tell me the reason why you want to choose the 1000 nodes in the input layer? Okay. So number of nodes I have to decide now. Yeah, ma'am, you're correct, but I am trying to take the guesses because people are giving different guesses. Now, Anita is saying that we should take 10,000 nodes. So can you just tell me the why? What is the reason why we are taking? Anyone else apart from the Ujula ma'am? Because we have 10,000 inputs. Okay, so that is the reason. Does anyone agrees that we apart from Ujula ma'am's opinion? That already know your opinion, but I'm not trying to discuss it here because I want to know from the people that what is their opinion, right? Anita is saying that we should take 10,000 nodes, right? 10,000 nodes. Here, since our number of images are 10,000. So are you guys, everyone agree with it? Or do you have any other reasoning? Yes, someone is saying yes, but I don't know. It is showing with something 17 RT. Apart from that, can you guys tell me that she's saying because we are having a 10,000 images, so that's why we should take 10,000 nodes. So does anyone agree with it apart from one person? Or are you saying that no, there should be different nodes apart from Ujula ma'am because she already gave me answer, but I have not discussed the answer here. So I want to know from the others also that what is their opinion, how much we should take. Shiv Prasad is saying that 28 by 28 equal to 784. Okay, nice, interesting answer. So I will try to write answers over here, popular answer. Since we are taking the dimension as 28 by 28, so 28 multiplied by 28 equal to 784. So number of nodes should be 784. Now this was the first option. Second option was given, right? That we should take 10,000 nodes since number of images are 10,000. And there is one more option which is given by Ujjwala ma'am. Probably I will discuss it later. Okay. So anyone else, guys, who want to try? Just can you just quickly tell me? I will take one moment, and within 1 moment try to understand the different inputs, because again we together going to design this one. So your inputs is needed, guys. Along with the input, Also tell me the reason that why you want to choose this many number of input nodes. Quickly guys, just ping me. So it will give us an entire idea that whether you guys are able to understand or getting to fit all this architecture back of your mind and how these things will work. So it will be a good exercise. Let's try to come to a common conclusion then, utilizing the different option given by the people. So anyone else who would like to guess voluntarily? Come on guys, quickly, because we have to discuss lot many things today. Quickly, just anyone apart from who is already answered. Like we have around more than 350 people, 350 people out here. So what's the harm in fencing your chances, guys? Let's try and give me answer that how many nodes I will be taking in the input layer and why, what is the reason for that? Quickly, guys. Who else want to try? What could be the logic? You guys already learned, right? How the artificial neural network works. Everyone is already aware. So what should be the number of input nodes apart from these three options? Or is everyone agreeing to these three options, or what could be the probable option? Then tell me, guys. Let me write also option which is given by Ujjwala ma'am. She is saying we should take 28 node again. One option is given as an 28 by 28, which is 7, right? 784. Guys, ping me on okay. Second option. Don't ping me on desktop, guys. Ping me on other one. So I will be able to see it. Desktop, I will later on share with you guys. 28 by 28. Ramakrishna sir is saying 28 by 28. Okay. So we are having couple of numbers here. Okay. So one again, someone is saying 784. Again, 28 by 28. So only two opinion as of now for 28 by 28. And for rest 784, there are 4 opinions. And 10,000, there is only 1 opinion. Okay, guys. Quickly just go ahead and ping me within half minute, 30 seconds time left. So we can understand and what should be the number. Komal is saying again, Vishwa is saying 28 by 28. Komal is saying 784, right? So 784 is getting more popularity over here. Vandana ma'am is saying 28 by 28. Okay, it's also getting popularity now. And 10,000 option, I will now erase it because guys, there are not much opinions. No one is trying to agree with the 10,000. Now the question is, real question is whether we should take 784 or we should take 28. Try understand this. There's a couple of more seconds and then maybe we'll try to close this quiz. Who else would like to try and please tell me the reason that why you are saying this number, okay? So maybe this will be a good exercise to understand how we can frame the neural networks. Already have an opinion, guys. We have a 5 votes for 28 by 28. For 784, we have 4 votes for 28 nodes. So quickly ping me that who wants to tell how many nodes should be there. Anyone else, guys, who wants to try any other logic? Quickly, guys, so we can go ahead then. That's it. These are the only opinions. All right. So I would say the winner is 28. Okay. Dr. Sudhakar saying 28. Okay. So this is 5 vote again. But I will say winner is 28. Let's try and understand why. Okay. So since what I told you that, what is the dimension? We are having 10,000 images, correct? And all these 10,000 images, right? This is number of images, guys. Try and understand. So that one is giving 10,000 number. But what is the real dimensions? 28 by 28, right? 28 by 28, correct? And that too into 3 channels, RGB, right? If you are giving a color picture, if you are giving a grayscale, okay? If you give a grayscale, that means normal black and white. So it will be only 1 picture. Now we are having color picture. So it will be 3 layers of 28 by 28 into 3. So why it is 28 by 28? Because that is the original dimension and then multiplied by 3. So, but let me tell you that it will not take like 28 by 28 multiplied by 3. That many inputs may be possible, but it will not try to take in this way. It will try to convert whatever image we are giving. Let it be a RGB image. I'm calling RGB image because it's a color image. So first thing it will try to do is it will try to convert it to a grayscale. So that is what it will do, because by doing this, we can reduce the number of inputs. So, but again, the information will not lose. Okay, the information will be present, but only the color intensity may vary, and it will try to retain the information. So my image size will become like 28 by 28 by only 1. Okay, if I am trying to convert them into a grayscale. Okay, once I try to convert them into grayscale, now I am left with this dimension, and what I can do is I can calculate 28 inputs out of this 28 by 28, right? So even though the pixel intensity is 20 by 28 by 28, it will try to take only one dimension out of it. One dimension in the sense it will be only 28 feature. Even though it's 28 by 28, it will be having only 28 pixel. Let's try and understand that. Even we sometimes whenever we try to click a picture in the iPhones or some other high-end cameras, at that time you may see a image as 1024, right? 1024 into 1024 also. And this will be again multiplied by 3 because it will be color image. So what we can do is we always try to understand whenever we are giving a picture, guys, whatever pixel intensity is showing, we'll taking not only whatever it may be, ranging from any dimension, maybe 700, 600, 200, 256, 1024, whatever it may be, whatever dimensions are given, we'll try to consider only one part, that is 1024. So even if they tomorrow provide us 756 by 756, the number of feature will be only 756 this way, guys, right? And anyhow, we are converting this color image to grayscale. So these 3 metrics will be nullified anyhow. So this way we should build our architecture, right? So now everyone has given a vote, and I guess everyone agrees that how many input nodes are there. Input layer is 1. Okay. Out of this input layer, number of nodes are 28, right? Because of our dimension. Now I want to understand from you guys that number of hidden layers. How many hidden layers should we choose? We already discussed this, right? So since we are going to create a very shallow neural network, so maybe we'll try to keep it simple. So just let's understand that any kind of hidden layers are possible, but we'll try to keep this as shallow as possible, right? Because we are not going into the depth as of now, just for the simplicity purpose. And again, why I'm telling you this, because you will try to understand these things when I will try to run this model. Because if I try to take a very depth neural network, so the training time will also be very high. So that is also purpose, and we need to create this architecture and make it up and running within this stipulated time only. That's why we'll try to create it as a narrow, right? Narrow or shallow. So I'm not going to take much of the hidden layers. Now the main question is, now I decided that I'm not going to take much of the hidden layers. Maybe I will try to take 2 or 3 hidden layers. Now the main question is, depending on this logic, that I have decided that my inputs will be 28. So can anyone just quickly tell me in my hidden layer, sorry, not in my output layer, in my hidden layer, as per the input, how many nodes should be there minimum? We discussed again this question last session, that whenever we are trying to create this binary class classification problem, at that time whatever input layer was there, accordingly we were able to decide also the hidden layer. So on the basis of the hidden layer, we also decided that how many nodes should be present in the hidden layer. So can anyone just quickly, now next question is to choose how many nodes should be present in the hidden layer. Can anyone just quickly tell me how many nodes should be present as per the input? Looking at the input, less than 28. Vijula is saying, Vandana is saying 28. Okay, now anyone else, guys, who wants to take? If I take, okay, I'll come back to this question, less than 28. Not less than 20, okay. Not less than 20, okay. So what we are saying is minimum 28. Correct, correct. Got it. Minimum 28 node should be present. This is what I have received the two options. Anyone else, guys? How many nodes should we take now? Minimum, we understood that minimum is 28, but what could be maximum possible? What could be the maximum, or what could be the optimal value over here? I just understood what is minimum number of nodes I should have, right? So now we are going to fix the architecture. So quickly, guys, without taking much of the time, just quickly go ahead and shoot that how this is the minimum number of nodes we should have, right? So what could be the optimal value, or what could be the maximum number we can take? Any opinion, guys, about it? Quickly, guys, ping me. Let's try to make it more interactive, right? So you guys will not get bored and you will try to become a part of this architecture, right? So I can see only a couple of people active here. Just quickly ping me that what should be the maximum number. Okay, Anita is saying again 128 or 256. Okay. So what else, guys? How much we should take? And also tell me the logic why you are saying this number. Okay. Also tell me the logic why should we take this many number of nodes? Come on, guys, because you will be a deep learning engineer or maybe architecture tomorrow. So you need to understand this thing right from this stage only. And what could be the logic? You should be able to explain. So when we are saying that you are a creator, 28 layers. 28 layers, you are saying Dell, someone joined as in Dell. You are saying 28 layers. I don't know your name, sir, ma'am, but you are saying 28 layers, 28 into layers. So you are saying minimum 28 or 28 layers or 28 nodes. Please clarify this one. And guys, quickly also ping me other guys meanwhile. So how many nodes we should take? Now the question is how many nodes should be there in the hidden layer? We decided that layers will try to take 2 or 3, not more than that. So within that, how many nodes we should take? Whether we should take the consistent nodes like in the hidden layer, or we should take a varying nodes. What I'm trying to tell you guys is I've decided that I will take 2 to 3 nodes, varying nodes. Ujjwala ma'am is again active. Okay, guys, what about others? Within these 2 layers, minimum 28 node, maximum 28 node, number of nodes. Okay. Okay, understood. So now next question is whether I should take, let's say I decide to take 2 or 3 hidden layers. Jagar sir is saying less than 28 and 3 hidden layers. Okay, good option. This one is also good option. The number of hidden nodes should be between the size of the input and the size of the output. Yeah, partially correct, ma'am. Vandana, partially correct, but I will not say that hidden layer nodes should be depending on the output. So partially correct that hidden nodes should be depend on the input size, but not on the output. Because I will try to again discuss this thing, then maybe you get answer to this question. But guys, next question is, so whether I should take a fixed number of nodes across all these hidden layers, or should I take varying nodes? That is also a question, right? We need to decide in order to create a robust model, right? Robust neural network. Now I am getting option that take varying nodes and minimum should be 28. That's what conclusion we have reached, right? So 28 node minimum and 3 lowers we are trying to decide. But again, I want opinion from you guys that, okay, Anita is saying varying. Okay, what else, guys? What could be the opinion? Should I keep consistent? Should I keep like 28? Or can I take like 28, 58, and again 28 this way? Also possible combination. Or should I take 28, 28, 28 across everything? Okay, tell me. And also tell me the logic why you want me to do in this way. What could be the possible logic for that? Logic could be anything, guys. Don't worry about the logic at this stage. So we're trying to just fence our chances. So these are our 3 hidden layers. So how many layers nodes I am taking? Whether I am taking 28 across 28 consistently, or if I am trying to take, let's say, varying numbers, or should I take like 58 in between? First layer I will take maybe 28, and after that 58, and again 28. This is also possible. So what could be the good option, guys? Since you are trying to create this architecture with me, so I need your inputs. Okay, quickly, guys, go ahead. Last 1 minute I will provide. And then if you are not able to answer, or if we are not able to discuss this, then I will start again going forward with the next steps. Okay, 28, 56, 28, 56. Okay, we're trying to double the notes. Okay, what the logic? So sir is saying that, ma'am is saying that we can take in this way. First layer we can take 28, we try to double them, maybe 56, maybe again come down to 28 in the third layer. So this is also option possible. Do you guys agree to this one, guys? This could be a good option. So let's take this one, or any other option, and why you are saying that this will work or this will not work. Please try to ping me also, so whether this will work or not work. So maybe then we can, without wasting the time, we can go ahead. All right, guys, if there are no more opinions, so let's try and understand. Praveen Kumar is saying varying and reducing number of nodes in the adjacent layer. In the adjacent layer will improve the probability of output. Could be possible, yes. One of the good option, yeah. Praveen Kumar. And then ma'am is saying that I think nodes in the hidden layer should not be more than the input. Yeah, but what I can say is partially correct again, but I will try to discuss and I'll try to answer this question, right? So what I'm saying is, whenever I'm trying to create this kind of neural network, so what is my minimum rules? So whenever I'm trying to consider about the inputs, right? An input has 28 nodes. This is what I understood. Then I have understood that I will try to create a shallow network. Why I'm trying to create a shallow network is the time, the parameters it will generate, because last time when we printed the summary, you guys saw that around more than 1,000 or 1,500 parameters were calculated, and those many weights will be getting updated at the each iteration. Let's say if we are taking 1,000 epochs, maybe 1,000 epochs, at that time 1,000 weights will be getting updated, and trying to imagine the computation power it will be taking and the time it will take to train the neural network. So this calculation has to be also taken. For that purpose, we are taking a shallow neural network. We have to decide the architecture. We have decided that we'll take a 3 neural network. Maybe I will try to create a different neural network, but as of now, we are try to decide this one. And then out of that, we are saying that minimum number should be 28. So what happens is, whenever we try to calculate this number of nodes, minimum number is 28, that we can agree, but varying number could be anything, or we can double the nodes also, or we can keep it more high. But again, it depends on, we should not go for immediately for the higher numbers. What we should do is, we try playing with the small numbers, and then after the iteration by iteration or by epoch, we should check the accuracy, and we should check how our optimizer is performing, if whether it is able to reduce the validation loss, and depending on the validation loss and the accuracy trying to achieve by every epoch, we can take the decision. So let's try and go back to our code, and hope this will answer everyone's question, and it will end the curiosity that how we can take. Now the last question before we go to the architecture, very simple question, guys. That tell me, now we have decided everything. What is input, right? What is hidden layer? Now the last question remaining is output. So here, obviously, everyone will agree that we will take only one layer, that is output layer. But again, same question, how many nodes should be there? What is the minimum nodes should I take? Again, this is the last part I am remaining for the go ahead. Once I get this go ahead, then maybe we can directly start the building the architecture, right? So guys, tell me last question now. This is the last question, that how many nodes should be there in the output? Everyone knows what we're trying to achieve, and according to that logic only, try to come up with a number. So tell me the number, that what will be the number of nodes in the output layer. Last question, guys. Come on, quickly. So Praveen Kumar is saying 10. Shiv Prasad is saying 10. What else, guys? 10. Can we agree to 10, or anything more than that required? Since this is not a binary classification, guys, this is multi-class classification. So the kind of activation function which we'll be using is also different. We'll not use a sigmoid or loss function as a cross entropy, binary cross entropy. So we'll try to use the different optimizer, different loss function, activation function. Just quickly, just try to close this question, guys, within 1 minute. So what will be the number of nodes? Now the response I have got is 10. Does you guys agree to this number? And if not agrees, please tell me quickly within a minute that what should be the optimal number then. What should be the correct number? If everyone agrees, just quickly ping me yes, yes. So we can go ahead and start building this architecture, guys. No need to discuss further then. So also you hope you guys understand why we are trying to take 10 or why we are not trying to take 10, right? So depending on that architecture also, we can go ahead then. All right, so no one is pinging me anything else. So I will assume that this is 10 and everyone agrees why we are taking 10, because the number of classes which we are trying to predict is 10. So obviously this will be minimum or max should be 10. So let's try and understand now. Let's go to a code. What we are trying to discuss over here is how my model should look like. So I have started with sequential, then model.add. First layer will be flattened layer, which is the input layer, and the input shape is 28 by 28. Now second layer, hidden layer, I have taken 128. Okay. So don't blame me again that we have decided that we'll take something around 28, 56 or something like that. Just this is the random number based on my experience and based on the permutation combination. I have decided that I try to take a more number, okay, with the hidden layer, because if I try to take more inputs maybe in the beginning, so it is maybe possible that within a less iteration, I will try to achieve a global minima. What is global minima again? It is the derivative where the derivative of the loss function will be 0 at the, again, global minima. We have trying to achieve by iteration, where my derivative, remember, derivative of loss function with respect to weights will be equal to approximately 0. This is what we are trying to do in the back propagation, right? Back propagation, this is the entire exercise to update the weights, right? In order to update the weights, right? In order to update the weights, we are doing all this exercise, and by optimizer using the stochastic gradient descent or maybe Adam optimizer, adaptive motion, right? Adaptive moment estimation, or maybe ADA grade, ADA delta, whatever kind of estimators are there. We're trying to take the help of them. Maybe if depending on the data, since we are using a small use case, maybe you depending on the data, you try to take a optimizer with the moments. We also try to understand whenever there is a too much noise in the data, so we should always consider the optimizer with the moments, right? So whenever I try to consider the moment, that means we are trying to give a weightage to a certain different outputs at a different layer, depending on the chronological order, right? When we try to update the weights. So let's try and understand. I have taken 128 as for the experiment, and I have taken an activation function as ReLU. Okay, I'm not taking sigmoid function again, because we have also seen that what are the limitation for the sigmoid, right? Whenever I try to create the sigmoid function, whatever that derivative will be between 0 to 125, then it will give me a vanishing gradient descent, right? And whenever I try to take a higher weight, it will give me a exploding gradient descent, right? Exploding gradient descent or vanishing gradient problem. So in order to avoid that, maybe I will choose a different activation function. So activation function, I decided ReLU. What ReLU will do is, the graph for the ReLU will look like this one. So ReLU will be giving me somewhere between 0 to 1 again, and it is the formula for ReLU is max of 0, comma y. Y is whatever number you are trying to provide it. It will take a max of 0 or y. If I give a y, it will give. If I give a y as 1, so it will obviously return me as 1. So the graph will be always look like this one. This is again going into the positive tangent, right? So this is the positive side, and the graph will always be looking like this, because it will always start from 0 and will be going as per the real number, whatever number you are trying to provide. Okay, so let's quickly go and understand. Then I have taken a ReLU, and then I have added a second layer. Now at the second hidden layer, I am trying to take the less number of nodes, right? Let's say 32 again, and the activation function will be ReLU, and then in the last dense layer, which will be my output layer, right? In the output layer, I will take the activation function as softmax, right? Guys, remember what is softmax? Formula for softmax will be something like this: e to the power y, thereby summation of all the e to the power y. If I trying to take the k classes, then summation will be from I equal to 1 to k. So this will be the function of softmax. It will try to calculate the probability and give you the probability according to the various classes which are available. So summation of I equal to 1 to k, right? Summation e to the power y, e to the power I divided by summation of all probabilities, right? So what is e to the power I? This is probability of one class of favorable class divided by probability of all the summation of all the classes. By this way, if you try to calculate the probability, it will always try to give a probability even if it's a multi-class between 0 to 1, and that's how we'll be able to identify the probability. So let's move ahead then. We have decided that we'll take 10 nodes. Why 10 nodes? Because number of classes are 10, and the softmax, obviously, I have explained why the reasons for the softmax. Let's try to run this model. Okay. So we already seen what is extrain. So try to create this model. Its model is created and try to print the model. Let's see how it looks like, right? So it's giving layer 3 because I have already added sequential function, run this function once. That's the purpose. Right? Just ignore about this 6, 7, 8. Number of times I'll try to run this. This will change. But anyhow, we are taking first layer, right? First layer, flatten layer, 28 by 28, right? And then it is trying to calculate the parameter. This is first input node, then second hidden layer, again 128, right? And third again 32, and then last is 10. And number of, look at the parameters guide it is trying to create, right? It is around 100,000 parameters it is creating in the first hidden layer, right? And then in second hidden layer, since I have, okay guys, if you have any questions, then maybe just ping me quickly. So I will try to take the question simultaneously. Raising hand will not help. Okay. So now we have taken like 4,000 parameters. Since I have taken a less nodes, so that's why the parameters are also less. And in the last layer, there will be 330 parameters. So look at the total parameter, guys. Even we have created a very shallow, very small neural network. Still, it is given us a 100,000s of parameter, right? 104,000 parameters, or 104 and 938, 938. So imagine total turnover parameter this much. So this many computations it will try to perform in the background to calculate the weights. So let's now try and go and compile our model. Within compilation of this model, I will take a loss function again by cross entropy, not binary cross entropy. That is already answered. Correct. So I'm taking sparse categorical cross entropy because how much time it will take for running the model, or you are saying for training the model, right? Yeah, training the model. Let's try and imagine within, let's say, 10 minutes it should be able to finish this one. That's was the last measure I've taken. So I will try to run this simultaneously here only. So let's see how it will update the weights and how it will give us. The loss function we are taking cross entropy. Optimizer again Adam, and matrix is accuracy. So already tried to compile this model, and now we try to run this model with 25 epochs. Again, I am keeping small epochs. So that's the purpose. And see here, guys, you were asking why it is taking 10,000, all this, but because at the time of the training, now I'm giving a validation split, take 80-20, right? So let's run this epochs and let's see within how much time we'll try to finish. Maximum should not take more than 10 minutes. If it's taking more than 10 minutes, maybe I will try to stop it because this model is already trained. Not even it will take 10 minutes. I think within 5 minutes, it should be able to finish the training. So guys, whenever we are trying to look at the training, try and understand that at the first epoch, right, the accuracy is 86% and loss is 50%, 0.50. And try and look at the epoch by epoch, how it is performing now. So all of a sudden from 86, it is jumped to 90, then to 92, and there is a significant change in the validation loss. So, okay, we have, let's say, more than now 20 epochs left. It's just the fifth epoch. Yeah, it's possible to execute in on the multi-core. So since you have to choose the GPU or TPU accordingly, if you are trying to execute on the TPU, or it is also possible that there are new technology which has come or new packages which has come, like the Hugging Face and everything, where Hugging Face, again, guys, is a platform where they're trying to provide you the platform to train the large neural network. And it is giving you like, there is a, let's say, package called as Auto Train. By using auto train, even or some other packages available, using that you can try to run the similar models which require the GPU on the CPU also, if you have a multiple cores. So that kind of settings also possible, or you can also give a option here. So how many jobs you want to run parallelly when we're trying to run these things. So that kind of option is also available. So this is the latest advancement that these guys have recently come up. That even within using the CPU also, you can create a lighter version of your model. And by using the certain platforms, obviously, in the background, they're using the platforms and packages. I don't know what exact calculation they are trying to do, but you can train them. Whatever model requires the GPU, you can train the same model using the CPU also with multiple cores. I hope this answers the question. Okay, guys. Meanwhile, we are still at a 15th epoch. So if you guys have any questions, please shoot. So within 2 minutes, I think you try to finish the training. And also try to look at the accuracy, guys. So since we started with the how much loss? 50.50, right? And accuracy at 86. Now try and understand after the end of this 18th epoch, right? Or end of this 17th epoch, we were able to reach to a 96%, right? 96% of the accuracy, and loss has been reduced to 0.18%. So this means that whatever nodes or whatever activation function and the optimizer we have chosen, they are working correctly and they're able to update the weights. So this is the indicator or symptoms by which you can try and understand that how your training is going on. What will be the threshold? Threshold will be again set up again. Usually it is like 0.5. So you can change the threshold also. There is a hyperparameter tuning available. On the basis of that, you can choose the thresholds. I have not given any threshold. It is taking automatically. Okay, at this moment. So whatever is more than 0.5 or 0.6%, it will try to classify that. Anyhow, in the end, we are giving the, let's say, and in the end, we are taking the probabilities only. So basis of the probabilities, whosoever gives the highest probability, that will the class, it will try to consider. It will not directly give us a class, that which class is this. It will directly try to tell you the basis of the probability only. On the basis of the highest probability, it will try to classify it. All right. So I think we are just approached to the end. Just within a couple of seconds, it should finish this. It's still running, so I'm not trying to disturb it. And look at this, guys. It's almost done. 25 out of 25 epochs. And see, we are able to achieve 96% of accuracy. Okay. So let's wait for a couple of seconds. Once this finish this thing, processing. I don't want to interrupt the execution. I want it to complete on its own. And then we'll try to check this. Okay, it's done now. Let's try to predict them. Model.predict test. So it has a around 300, right, data points in it. So it was able to predict. So this is again just to align the output. And then we try to understand what is the accuracy. Okay, guys, 96% accuracy. Correct? We were able to achieve the 96% accuracy. Let's try to plot our loss graph and try to understand how this model performs. If you can see epoch by epoch, on x-axis we are seeing the epochs, on the y-axis we are seeing the validation loss. Let me try and understand. Okay. So if you see the loss after, let's say they're trying to drop till 10th epoch, right? After 10th epoch, there is still some gap, right? This kind of gap is there from even, and after even 20th epoch, the distance is getting higher between these two curves, right? Validation loss and the test loss and the validation loss. Okay. So what does this mean now? Okay. how should I try to analyze this graph? So if I see that both the graphs are trying to submerge like this way, then that will be a good part, because I can see that both the losses are getting simultaneously reduced as the number of epochs are increasing. But in this case, it is not the picture. So after certain epochs, let's say after this epoch, there is having a gaps in between, right? Will it suffer from local minima and global minima? Yeah, that's what I am. Will it suffer? Okay, from local minima and global. Yeah. That has what it has to do with the graphs and with the thresholds. The correct understanding, but I will try to explain. Maybe at that time you will get your answer. So what is happening over here is I can see a little bit of overfitting, right? The overfitting happening, not much overfitting, but there is overfitting, right? What do you mean by overfitting? If there is no consistency in the reduction of the error or predictions, right? So I can see a gap over here after this. So maybe by just for the prima facie investigation, when I'm trying to do a prima facie investigation and trying to look at this, my loss function, right? What I can analyze is my model is trying to overfit on certain scale, right? I don't know scale yet, but what I can understand is there is still scope, right? There is still scope for the improvement, right? Scope for the improvement of the model, or maybe I can try to do a hyperparameter tuning. Okay. And again, I told you that what do you mean by hyperparameter tuning? Again, we'll try to understand this one once we analyze our accuracy graph as well, right? So what it denotes is prima facie or on superficial level is that at certain extent there lies the overfitting. This is downward sloping graph. Yeah, guys, this is downward sloping. That's what we're trying to analyze. This is the graph of, guys, try to understand, guys. This is the graph of loss, right? So that's why it should be downward, right? What is my purpose? Try to minimize the loss. That's why it is downward. So that is the correct trend, guys. They are in loose. What do you mean they are in loose? Ayush, I'm not able to understand what you're trying to convey. Can you just please write it in a better way? They are lost. Okay, loose. Okay, they are lost. That's why they are trying to get reduced. But even in the loss, there is not a consistency. They are not trying to get merged with each other. There is small difference in it after certain epoch. So this conveys me that there could be a small overfitting also possible, or maybe there are chances that I can improve my model. Okay. So by understanding this, let's move to next graph. Now, next graph is for the accuracy, and by epoch, try to understand how our model perform, right? So we started with the epochs, and even here also you can see a validation accuracy. Let's say this is a validation accuracy, and this is our test accuracy, because in the end we were able to get accuracy as around how much percent? Around 98% or something like that. I'll try to look at it. So even here we can see that there is a difference, right? So there is also scope for the improvement of the model. Okay, this is what the primarily I can say. I will go back to the parameters. I will try to show you what do you mean by parameter hyper tuning. So let's try to understand the next thing. Now you're saying now everything is there. Now you're saying that okay, accuracy part which I'm trying to get is 96%. Now show me how it's trying to identify. So X test, what I gave image was this one first image which was showing this way to right. Let's try to execute. This was the image which I tried to pass here, right? X test, same image. Now I created a model. My model dot predict. I will try to pass this image and try to understand whether it is able to understand it, whether it is correctly trying to predict it or not. Again, guys, why I'm trying to reshape over here is, if you could remember, when I took at the time of the training, I try to make them a scaling, right? I created a scaling by dividing them by 255 by 255, and then I created a scaling, right? Standard scaling, like we do in machine learning also. Here we did a standard scaling. So that's why whenever I try to give model or image to my model, I have to again give it in the original shape. That's why I'm trying to reshape them as a 28 by 28. That was my original dimension. Let's try and run this one. Okay. So it's giving 2, right? So it's able to correctly identify the image, right? As a 2. Let's take another example. Maybe I'll try to take randomly something like 7. Let's see what is 7. 7 is 9, guys. Okay. 7th image is showing 9. As per me, it's 9, but let's try and understand how this model will be able to identify. If you could remember, initially I was trying to tell you that if I have a less number of data, maybe at that time I'll try to make a data augmentation. What do you mean by data augmentation? This is a beautiful example, guys, because usually what we do is we try to write 9 like this in the image, right? And this is somewhat tilted, right? Not in the correct 90 degree. It is somewhere between the 45 degree, right? So this is also possible by tilting this image up to certain degree. I can create a new image, and this way I will be able to have a multiple data set available with me using the original data set. So that is how the data augmentation will work, and that is really used by the deep learning scientist or machine learning scientist in order to create an extra data set. Because simple rule, if I have a more data set, then more patterns will be identified, and the more number of pictures it will try to get into the training data set, and the robust prediction will be done. Okay, so this is a good example. Let's try and understand if it is able to successfully predict it or not. Right? Not 9, it is 7th rank. This is the number of 7th image. So 9, correct, guys? See, so our model worked. This proves the hypothesis that even this kind of shallow model will be able to predict us if you are trying to prepare a good quality data set, and also choice of activation function and number of input layers is also important. Correct? Isn't it amazing, guys? So within even 3 layers only, we will be able to solve this case. Now, what I mean by hyperparameter tuning is when I am saying that whenever you're trying to pass this kind of parameters, right? These parameters like let's say the activation function, softmax function, right? You're trying to provide number of inputs, right? Even when you're trying to pass the loss function optimizer, matrix accuracy, or validation split for this purpose, all these parameters we can tune them. What do you mean by tune them? I already told you that there are 2 or 3 popular algorithms. One is random search CV. Okay. Random CV, random search. Okay. Random search CV. And this another one is grid search. Okay. Try just ignore my handwriting because it is really not good. In reality, even I'm trying to write it in a better way, but using mouse, this is the worst handwriting I'm able to generate. Okay. Ignore, pardon me for that purpose. Okay. The second one is grid search CV. Okay. And third popular algorithm is Keras tuner. Okay. Keras is the package, right? API we're trying to use, right? They're also having this Keras tuner functionality available. Okay. So these are some popular algorithms by using which you can give the multiple options for these parameters, optimizer matrix, right? Or whatever kind of layers you want to use, or whatever parameters you are trying to achieve over here in terms of the activation function, optimizer, or kind of the split you are trying to achieve, or number of epochs for that purpose, right? All these parameters can be passed, and you can give a range. Let's say you are saying a parameter for the epochs, right? Here we have taken value less epochs. Maybe you can provide a number like 0 to 200 epochs. And for different combination and permutation of this number of inputs you are given, or you can say then optimizer as Adam, right? Adam, or SGD, stochastic gradient descent, or ADA delta, ADA grade, right? This kind of option you can provide them, and it will try to create the iteration with using different combination. And after that end of this parameter tuning, it will try to give you a best parameter, and along with the number of accuracy. So obviously you can go for higher accuracy. We can choose this best parameter. There will be often option called as best parameter, best underscore pair of params, something like that kind of option is available, right? You can easily take that option, which will try to print you the different values for which you got the better accuracy, and you can directly now input those new values over here and then try to rerun the same model, and it will be able to achieve the optimal accuracy. Clear, guys? Any doubts now? Or you want to make any changes to this neural network? So this proves that our VIX network, right? We gave this number name VIX, Vikas in the class. So we were able to successfully run, right? We achieved even a very nice accuracy around 97%, right? Any doubts, guys? How we can do multi-class classification? Clear. Okay. So for everyone, it is clear, right? Pretty simple. All right. Okay, couple of yes, no, guys. Maybe then we can start with the chatbot. Okay, how to create a chatbot using Google Dialogflow. Okay, Ujjwala ma'am is also saying yes. So couple of yes, no, guys. Or any other doubts you have regarding the parameter? Or do you want to experiment anything else with this one? But can you please also explain how the accuracy changes on the change of epoch? Yeah, that is possible, guys. Even if I change the epochs, again, it is not guaranteed, guys. Ma'am is saying that, Vijaya ma'am is saying that how it can change. Accuracy can change over the change over epochs. So it is also possible. Let's say here I am taking only 25 epochs, but what is the logic behind this one is that within 25 epoch, maybe my neural network is not able to learn. This is also possible because I have seen such cases where if you like, let's take an example. I will give you a real-time example where we are trying to create a object segmentation model using YOLO. Okay, YOLO is a model, pre-trained model, okay, provided by the PyTorch. Okay, Facebook PyTorch model. Okay, so this is the model which is given by the Meta, right? Meta, now it is called as Meta. This model I was trying to run. So imagine we run this model for 5,000 epochs on my Linux system, and it was running like around 12 hours. Okay, so I was not using GPU, I was using CPU. I just created a setup using the CPU. There is also option whether you want to set up using CPU or using GPU. The cafe is the library, and using this library, they will try to give you different directions or different instructional sets. Using this instructional sets, you can set up this model on Linux machine, and imagine it run for 12 hours for this 5,000, not 5,000, 50,000 epochs. Around 50,000 epochs, I try to run this. YOLO, what is YOLO? YOLO is you only look once. Okay, guys? YOLO means you only look once. This is a popular algorithm which is used for the, and there is a latest version, YOLO 1, 2, 3. Okay, and there is a new version called a YOLO NAS. NAS, YOLO NAS. This is the latest version which was published last month, okay, by the Meta. And this model is really amazing model. This is able to give us a real-time segmentation. What do you mean by real-time segmentation? Is it gave a feed of the live, okay, live signal camera, and on the basis of that, it was able to predict with this fast accuracy and with this fast speed of the motion, it was able to identify the cars, trucks, people, human signal and everything. It was able to identify out of this video feed, right? So that is a beautiful model. Maybe let me try to show this model to you guys, if possible. At that time, if you see, if I try to run, why I am trying to tell you these things is because it has to do with the epochs. If I drew a very small kind of epochs at that time, maybe this will not be able to give us the highest accuracy or robust model, right? So that's how the number of epochs plays a very great role. Okay. So let me search this NAS. YOLO NAS. Maybe try to understand how it is performing. Images, right? YOLO NAS. Remember this way. You could see this picture. This is how in real time, with the real time feed, it is able to identify, and you can see these bounding boxes along with the probabilities. The small numbers are probability. What is the probability? This is backpack. What is the probability? This is backpack. What is the probability? This is cap. What is the probability? This is car, and everything, right? So this is a real time feed. You can identify the people, identify the person, and you can track them. So this kind of models are also available, but they require a highest number of epochs in order to get the accuracy. So I hope guys you are able to understand everything, and now you guys have enjoyed this one. So quickly give me just 1 to 2 minutes so I can adjust my screen and I can make some necessary adjustment, and I will take you to the chat box. Okay, chat bot. Sorry, I will try to create a chat bot. Just give me 1 minute of time. Okay, within 1 minute, I'll try to make some necessary changes and I will try to share the screen with you guys. Just hold on for a minute. All right, guys, just a moment. I will share my dialog box screen with you guys. All right. Okay. So this is how the dialog box will look like. Okay. Let's try and understand the things from the beginning. Before even that, try to understand that how these chatbots and all this stuff has started, right? So if you guys could remember, there was an industrial wave. In that wave, people started with the concept of BPO, right? Business process outsourcing, right? Business, just please pardon me for my handwriting and spellings, right? Business process outsourcing, right? Go for outsourcing. So what happened during this BPO phase is people were trying to shift their services, which are not the core part of them, right? Not the core services. Let's take example that there is a company called a GM, General Motor, right? In the back in the States. This General Motor, what they decided that while doing restructuring of their company, they decided that my business or the main business of the General Motor is to create the cars, right? In terms that should be their focus area, right? Creating the cars, not on the after sales services, right? Not on the after sales services, right? Not to focus on after sales services. My job is to create car and I am good at it and I will try to focus it. So what will be the solution if I want to focus on just manufacturing of the car, right? So it is possible that I'll try to outsource the work which is not my core work. For that purpose, customer centers, right? Customer centers or customer support centers. So then there was a huge wave that how the entire companies thought that doing a business process outsourcing, we can just source the unnecessary or a non-core part of our company, which does not require a high-end technical part. So we can source these companies to the emerging countries, emerging destination countries, where there are most of the English speaking users are there. English speaking users. which can handle this customer support, right? Which can handle the customer support. So that was the idea when entire call centers were shifted to the India and some Asian countries with a low cost approach, and they wanted to focus on more approach. At that time, what used to happen is whenever you try to call to a call center, so there will be obviously huge number of people working, right? Already they have hired many people who will be handle the call, right? Where they will be able to handle the calls, right? Handle the calls and able to solve the problems of the customers. Solve the customer problem. So there could be mostly the inquiries like if I have to schedule my servicing, right, of the servicing of the car, or maybe spare part related issue, warranty related issue, or some kind of issue, or some kind of specific domains I'm talking about. So what used to happen is first call center has to come up with the large scale, like large number of people they have to retain. Also, they have to provide services to the customers, and they have to provide a 24/7 services, which was not possible, right? They used to give a services to the limited time, like limited time zone. Maybe if the customer center is in Asia, maybe they try to run the night shift couple of hours, but they will not be 24/7. But afterwards, they switch to this 24/7 criteria, right? That is also possible. But let's imagine customer one calls in, he has to wait for some time, then he gets into the queue, and after getting into the queue, right? Once customer one calls in, he has to wait for some time because obviously there will be some wait time. Then you have to press certain kind of idiot buttons. They say go for menu, this one, press two, press three, press that, and then you will try to connect to a customer executive, right? Customer executive, they'll try to speak with you and try to resolve your experience, and maybe you will get a feedback. You will get a feedback accordingly, right? So every time the customer to calls in, it is not necessary that whatever experience you are having as a customer on, maybe not possible that similar experience you will get as a customer too. Maybe they are not satisfied sometimes, right? So there is an inconsistency, right? Inconsistency in terms of the customer support also. Again, you have to wait, you have to do all these things. So at that time, the people decided, what if we can do something about it using the AI technology? And that's how the chatbots, okay, chatbots came into the picture. And using the chatbot, what was the benefit? They are available 24/7, right? The user experience will be same for everyone, because they will most probably treat everyone, and you don't have to wait. No wait time, because no wait time, and there will be less resources, right? Less resources means less cost associated with. So all that, because of this revolution, the chatbots become very popular. So that's how the thing started. And then previously chatbots, right? The chatbots, even if you go nowadays, if you go to any website or any company portal, right? So you will ask someone called as, hi, I am Alexa, or some kind of person, or hi, I am, let's say Vector, how I can help you, right? This kind of chat box will appear. You'll try to chat with it. It is available 24/7, and it will be able to give you some frequently asked questions, right? Frequently asked question. What is the chat box are there in the WhatsApp, Snapchat, Facebook feed information? They will send you all the messages the way the system generated. Then we say hi, they give us an answer of hi. Yeah, correct, guys. That's kind of architecture, right? That kind of architecture, because they are also the bots. I understand bots. They're also bot. They are trained on certain data, right? They are trained on certain data, and on the basis of that limited knowledge, right? Limited knowledge, they will try to answer you, right? Try to answer you. That's how the bots are there. You can make these bots. That's what we're trying to understand, guys. So we're trying to understand how we can create this kind of bots, right? So any kind of bots, whichever you are seeing, which will be able to, where you will be able to chat and try to understand certain question and answer on the basis of some rules, they will be able to answer you. That kind of things or technology we're trying to develop over here, and that is called a chat box. But our chatbots, sorry, are not dumb. Okay, they are AI enabled, powered by AI, and they will be trying to understand the NLU. What do you mean? NLU is natural language understanding. So there are two type of bots, guys. Whenever we talk about the chatbots, one chatbots is based on rule based, and one is NLU based. Okay, one is NLU based, one is rule based. Rule based chatbots require spatial handling skills, spatial handling, and requires a technical person to handle them. So based on certain rules, it will try to give you answers, maybe for technical purpose. But these NLUs are very popular. This means natural language, right? Natural language understanding. They have a natural language understanding just like us. We speak English, Chinese, Japanese, Germanese, or whatever language. And for that purpose, our regional language, for all the regional language, we try to understand, try to get the things out of it, and then try to reply. So how the things works, let's understand and what we are trying to achieve over here. So we'll create a bot, guys. We'll create a bot. This, let's say this bot using the, and before even try to go into this bot, so there are several products which are available. Using these products, we don't have to start anything from the scratch. So there are certain popular platforms available. The first one is Google Dialogflow, which we'll be using today. And then there will be Amazon Lex is also one available. Then there is a Rasa NLU is there, right? Then there is also one more product available from the Microsoft, right? Microsoft is having Louis. So these are the popular platforms which are available, where you don't have to write anything from the scratch. They are created on the basis of the NLP models, in the NLP models, NLP algorithms, and they are giving you a basic platform, right? Basic functionality using which you can customize your chatbots, right? And you can train it for your own purpose. So let's try and understand, okay, how we can create the one. And now for that purpose, I have chosen a Google Dialogflow. Google Dialogflow is somewhat simple in terms of the interaction, user friendly. That's why I'm choosing this one. But you can do it on any other platform. And what you have to do is, before even you try to get into this Google Dialog platform, you require a cloud account, right? Google Cloud account. And most probably it will ask for the credit card information, because payment information or something like that. And it will not, okay, obviously they will not charge you initially. They will not charge, okay, but they will try to ask the information for the credit card. And later on, when you are done with the free trial, they will try to give you a 3 to 6 months of free trial. Okay. 3 to 6 months of free trial is available. So after that period, you will be get charged. There will be billing activated, and they try to collect all your billing information well in advance. Then only you will be able to access this one. So whosoever having a credit card with them, they can create this account, and maybe you try to follow this kind of thing, which I'm going to teach you guys here. Okay. So let's try and understand what we'll do and what will be our business case. So we'll try to create a chatbot today. And this chatbot, okay, it will be able to do what? Whenever a user try to interact with it, so user may be saying hi first time, and then he will be doing the greetings, right? That kind of greetings he will do first. Once he is able to do the greetings and all, so we'll try to ask further certain question like, what is your name, right? Sorry. What is your name, right? Who are you? How can you support me, right? Kind of support he may ask. Or what we're trying to do here is, we're trying to create a simple chatbot which will try to interact with the user. You will try to greet first. After greeting, it will ask you, how can I help? And after that, he says, okay, tell me the weather. Tell me the weather. And when he will ask for the city. Okay. Once you provide the city, it will be able to give you the accurate temperature. And along with that, humidity, wind speed, and some other characteristic, right? And how it will do is, it will call a API, will call an API, okay, because you cannot do it on its own. It will call an API called as Open Weather Map, OMW. This is the popular API which is available, and for that purpose they have created a OMW package also in the Python. So what our bot will do is, we will try to greet with the user. It will try to understand that what he's trying to tell you. So he's asking for weather, then in fact it will call a API which is OWM, and this API will be exposed using the Python file, right? We have already created a function in the Python, a Flask API, right? A Flask API. Let me clarify everything. A Flask API, using the Flask framework, we have created a API, a RESTful API, okay? A REST-like API. This REST-like API will try to access the Open Weather Map site, and from that site, it will try to fetch you the temperature, humidity, wind speed, and some other information of the current weather, right? Current weather information. This is the end-to-end functionality which we want to do. And before that, it will be also able to answer the FAQs. Okay. So I'll try to tell you that how to upload a file or how to upload the FAQs. And on the basis of this FAQ, it will try to reply to a user. And once, if it is not satisfied with the FAQ, he want a further complex functionality. Or in this case, guys, I'm taking example of weather, right? Try to understand, if your guys are doctors, engineers, or some other professionals, so you can have a bot which can book an appointment, which will help you to book the appointment in your Google Calendar also. That kind of API is also available. Or try to create API which will try to integrate to your FAQs, and on the basis of that, maybe you get a tracking of your products. Let's say it's an e-commerce company. If you're working in an e-commerce company, maybe you try to track the package which you order, some package or shipment details, right? This kind of things can be also possible using this kind of chatbots, or even high level of interaction is also possible, but it again depends on what kind of APIs you're trying to live. Or try to take a very simple example. When you go to a bookmyshow.com, right? Book my show. It will try to ask, I want to book a movie. So you will ask for the what time and what date, right? And what kind of show you want to see, which movie. And on the basis of that, it will be able to book your ticket, right? So that kind of options is also available using the chatbot, correct? So that, or you can take a very popular example like railways. What railway has done is IRCTC, they have exposed their APIs for everyone. So maybe using this IRCTC API, that's how the other different websites like goibibo.com, Book My Trip, Trivago, or some other things are there which are able to book your, right? Book your flights or trains, right? Flights and trains, and that will be done through the chatbot. That is also possible, this kind of chatbot. So this kind of use cases are also available nowadays. Even the chatbots are getting up to advanced level, where kind of imagine like Alexa and Siri. And these are a simple chatbots, but even they are a high level of chatbots which will be able to tell you or become your personal executive assistant to help you based on the data, right? So what we'll do is, like I told you previously, that this is a subscription based packages which are tracking. Obviously, this is free trial for 90 days or 3 months, right? And after that, they will try to charge you if you try to use. So good idea, suggestion is try to create an account with the Google with a fresh email ID, right? Fresh email ID. And then whenever you go to this account, let's say, search this dialog flow. ES, there are two kinds of dialog flow, ES and CX. CX is advanced level, but we're going for ES, the small level ES, right? So when you go to this dialog flow, this kind of things will appear. You have to go to console, right? Once you click on go to console, this kind of things will appear. In the console, it will ask you whether you want to create a new chatbot or you want to go with a previous one, create a new agent, right? Create new agent. And once you click on create new agent, and it will ask you the name. Like say in this case, I have a given demo, and then try to save the things, and it will ask for some options like what time zone you want to save, and do you want to give any name or description. This project ID will be created by default, and that's the only settings you have to do. And then you click on save. Right? This is just the simple how do you create an agent. This dialog flow agent called as name demo. I have already chosen a language as English. There is an option also to choose the different languages. But try and understand what we're trying to achieve over here is we have to create a simple demo. So maybe today we'll not be able to integrate the API and everything, but still I will try to go ahead and start with the topic and try to understand that how far we can cover this one. But even to expose this chatbot with the API and everything will take some time. So maybe we will try to cover that, but just we are only having 20 minutes. So let's try and understand how we can finish the maximum things. So this is very simple, guys. Once you just come here and create a new agent and give an information, particular information, right? Don't bother about other things. There is also option about delete agent. So whenever you are done with this thing, you can delete this agent also. So once you go to this general option, give a description, time zone, and maybe you can also choose the language. Here I've checked as English. Delete agent means, guys, you're trying to permanently delete this chatbot. That is delete agent. Okay. And there are certain other options are available. Don't try to play with them. They're like import, export, environment, speech, and everything. Just go for the simple option, general. In general, you just give a description, name, time zone. Project ID will be automatically created because whenever you try to create any new product in the Google Cloud, it will create project first, then only it will ask you to enable the API. Maybe some of you will say that we did not get this to directly this page. Okay. So what will happen is first, whenever you try to click to this cloud console, right? Like this one, whenever you try to click on console, at that time, let's say go to this console. Now it is giving me directly to Google Dialogflow CX, but for you guys, since you will be new one, right? Like this one also. Now see, I have not created the Dialogflow CS. So it will ask you for the project. So these are my project already, which I have created. So I'm trying to cancel it. And once you select the project and click on everything, it will try to ask you one option. Like let's say that option will be enable the API. Whenever you try to work on the Google Cloud, guys, GCP, maybe some of you are aware, always you go to the API options, right? API options, API will try to understand afterwards. API try and understand that like the products, right? Different products which are available, and you have to enable that API, right? There will be one option on this entire screen where it will be saying that enable API, right? This kind of option will be there. Enable API. If hit on enable API, it will try to give a list of all possible APIs or products which are available in the cloud. Out of that, you choose a Google Dialogflow agent, a Dialogflow agent. Okay. And hit on enable. And once you hit on enable, then it will take you to the screen just like this one. Right? This screen. This part is clear, guys. So you have to first log in. You have to provide your credentials, create an account, new account. Once you create a fresh account, it will give you a free credits, which you can use for 3 to 6 months, right? Depending on the option you are giving. Most probably you have to give a credit card details, right? In credit card, they will not charge anything, but they will try to deduct 1 rupees in initially, so they can authenticate the information. It's paid, not paid. It is free, but you have to give an information. Once you are done with the free trial, then it will become paid. Okay. Initially, it is free, guys. Try and understand. They will try to give you some credits, right? That credit will be used for at least 3 months, 90 days. You have a grace period, right? 90 days, which is free of cost. This is not fair, but this is the way, guys. They are not for charity. They are a company which are profit-making company, right? And even out of that, they have given this option of the 30 to 90 days of free trial. Okay, 90 days of trial. So what you have to do is to activate this trial, you just have to give your credit card information. They will not charge you anything. Initially, they will try to create one simple transaction of, let's say, rupees 2. Okay, 2 rupees transaction will be deducted. Once this is approved, then that means they will confirm that, okay, this is the genuine credit card information you are given. On the basis of that, they will try to activate everything. Don't worry, just it will be cost of 2 rupees. I think everyone can afford 2 rupees for creating such an amazing chatbot, right? So once it is created and once you are done with this one, you can delete this account. So they will not charge you anything further, right? So all this credit card information also, you can delete that. Attendance link is already shared, guys. So try to focus on this one, right? It is already shared by Amar. Try to understand what we are trying to achieve. So we'll try to keep things simple initially for the chatbot. Tomorrow we'll try to go into a complex version, like where we'll try to integrate the APIs. Integrate the API and some sort of, let's say, exciting coding part where we can directly link this to Telegram also, if you want. We can create this demo, this whatever chat box is created, you can directly link it to Telegram or some other option. Most probably, I will try to show with the Telegram. Okay. So how to create API and everything that I will take you into detail. Try to understand initially how to start. Okay. So what I was telling you that it is just the 2 rupees you will be get charged, and on the basis of that you can have this free trial. So once you come to this is how the window will look like. And here what you have to say is try to understand certain things which are available here, right? What do you mean by intent? What do you mean by entities? What is knowledge, fulfillment, right? Don't go for integration. Integration is like, these are the different options, right? I was telling you. You have a Telegram, you have a Slack, right? You have Messenger, Facebook Messenger, some Viber option is there, Twitter is there, right? So that is called as integration. That's what I was talking about, right? Let's try to understand from the first things. Once you try and come to this intent, right? What do you mean by intent? Let's understand what do you mean by intent. When you first time try to chat with the chatbot, let's say, how you start a conversation? Hi, hello, or some sort of things, right? Hey, what's up, right? Yo bot, what's up, right? That kind of things you can try to fire at it, right? So for that purpose, what do you mean by intent is to try to understand using your keywords, right? This kind of keywords, you'll try to understand your intent. What is your intent? Maybe intent in this case could be, what you can say is greetings. Means you're trying to say, hey, how are you? Something like that, right? Good morning. This kind of greetings, right? Good morning, afternoon, evening, something like that. So that is called as greetings. That means whenever the first time we speak with any humans or anyone, we try to greet each other, right? The same way bot will do, right? So you have to understand, it has to understand the intents. So first intent will be greetings, right? So now you understand what do you mean by intent, right? Intent means try to understand the logic behind the speaking, right? Whatever you're trying to figure out after that, it will try to take a keyword. On the basis of that, it will try to understand the expectation from the user. So that is called as intent. So it will be a greetings intent. Once we create a greetings, right? Then maybe you will, what is our use case? You will ask that. After that, you directly ask for the weather, right? Once you ask the weather, the intent will be weather here, right? That means you are trying to inquire about the weather. And once you ask the weather, we can also make these things mandatory. Like you can ask, what can ask you for the city, which city, right? Because that directly, if you tell a weather and the bot says like, oh, it's a good weather, doesn't make sense. So you will ask for the city, and on basis of the any city in any world, whatever city is there, you try to fetch the temperature, right? Wind, humidity, and some other things, right? So that's what we'll try to do. You give any sort of city available in the world, we'll try to fetch the greeting, fetch the temperature information. Okay. So now you understood what do you mean on greeting. So let's try to go into this intent. When you try to first create this intent or go to this intent option, it will have this by default 2 options. One is default fallback intent, and this one is welcome intent. So let's go into that. Try to understand. Welcome intent means first time whenever you try to chat with the bot, so you try to welcome you. Okay. So that will be the welcome intent. So once you go to this welcome intent, right? So just forget about the context and events as of now. Okay, training phase. This will be the first thing. What do you mean by training phase is you have to train your chatbot, right? That what kind of greetings and on basis of what kind of greetings you should reply to a user. So for that purpose, we have a training phases. So what kind of training phases? Here you have to write the training phases like this one. I've written how, good, right? Just going to say hi, yeah, right? Hello, hi, how do you, right? Hey there, hi there, greetings. Hey, or you can say good morning, right? And hit enter. This kind of phrases will get added, right? Good morning, or just simply good, anything like that, whatever you feel, but we try to make the generalization over here. So first will be the welcome intent. In that, you try to add the sentences, right? You try to add the sentences in a such a way that you are trying to guess now that whenever first time any user, how can we add this chat box in the following social media? That I will tell you guys. That is called as integration. That I will tell you tomorrow. This is a simple process that will be done through this option integration. Okay, that I will tell you. So what we're trying to understand is first the welcome intent. In welcome intent, we try to guess that what kind of phrases or kind of sentences which user will use in order to greet or say welcome, right? Good morning, hey, how are you? Just going to say hi or hello, hey there, right? Hi there. Now it is possible that you try to write as many as possible, or you can write like something, few of them, which are very common, correct? Once you say this training, then obviously next part is once the bot understand that these kind of keywords or you come across this keyword, what should it do, right? Next. So that will be coming under response, text response. So once you say bot, hey, hi, how do you, what's up, bro, right? Hey, chatty, something like that, or anything, right? So people are very weird, guys. If you cannot imagine that the way people try to tweak the chatbot, let's say that a chatbot, they will try to find out some kind of mimic in the conversation and they try to bother the chatbot. So that kind of response, right? That kind of, let's say, again, we are using the concept over here of the human feedback, right? Human feedback. So remember, I spoke about this reinforcement learning, human feedback. Right? This is very pretty advanced concept, and this concept is nowadays used in the chat GPT, right? What do you mean by this is we're trying to guess, or we're trying to guess from the human point of view that when I'm trying to speak with a certain humanoid bot or humanoid person or human, what kind of reactions I can have, right? At least not I just cannot go ahead and create everything, right? Or I just cannot go ahead and try to understand each and everything, but at least I can come up to certain common ground, right? At least this kind of common phrases which are also possible. And if my bot is able to identify it, then how my bot should give a response, right? So it's again, guys, we understood from the artificial intelligence point of view also, right? So how we can, what is artificial intelligence or human bots? That they are trying to take a human feedback or try to think like a human and then try to answer this question, right? So let's answer. Let's try and see that. So what we'll do is we try to write a training phase, and on the basis of that, we'll try to write this. Hi, how are you? Hey, how can I help you? Good day. What can I do for you? Or greetings, how can I assist you? This kind of responses you can write here, right? You can add any additional response or anything like that. And then once you write that, here also you say, just like to make it more interactive, what's up, bro, right? What's up, bro? And then you try to save this one. Once you save this one, it will create a training in the background and try to save these things. Now let's try this one, right? How it says, what it says. So what I will do is I will try to start, let's say, with first thing. Hey, right? So see how it is responding. Good day. What can I do for you, right? So what it's trying to do here is it identify. Let's go to this thing. It identify the intent, which is a welcome you're trying to do, right? On the basis of that, it took action input dot welcome. right? And it was trying to predict even sentiment, and sentiment score it was trying to predict here, right? So in the background, we can understand that it's trying to predict the sentiments. In the background, NLP models are working, right? And they try to understand your sentiment, and they're trying to understand your intent. On the basis of that, they're trying to give you a reply. So again, let's say whenever you are creating a bot, or you get if a kind of a similar response, so it will become more mechanical. So for that purpose, we are trying to add this kind of sentences so that it should look like a human to human interaction. Let's say you again go back here and say, how are you? Let's try and understand how it will respond. So it's not able to understand how are you, right? Because you are not giving it, right? Let's say HW. See, if I give only HW, it is saying, okay, good day, what can I do for you today? Or hey there, or hi there. Hi there, right? So what's up, bro? Remember, we gave this sentence. Lastly, simple, we see the information they will work for us as we are giving any commands, right? See the information they will work as we are giving any command. No, guys, not this way. Try to understand that there are certain things we have to configure over here, right? So this way we have to create the intents, entities, knowledge, and on the basis of that, this chatbot will be created. Or you can pursue the simple way also. But what I'm trying to convey over here is there will be intents first. So this was a intent, greeting intent, and there will be something called as fallback intent. Now try and understand fallback intent. Fallback intent means whenever you are trying to give any information which my bot is able to understand, it should be able to handle that. That is called as fallback intent. Means whenever the bot is not able to understand anything, whatever you are giving. So let's say not able to understand anything. So saying sorry, what was that? Right? So if you look at the intent, this is the fallback intent. Input is unknown, and it trying to see the sentiment score, right? Over here. On the basis of this, trying to understand. So there should be something. If it doesn't understand, then it should be able to give you a overview or give a response and try to handle that response, right? For that purpose, we are added. I did not get that. Can you say it again? I missed that. What was that, right? Sorry. Can you say that again? Sorry. What can you say that again, right? Can you say that again? Sorry, I did not get that. Can you rephrase, right? One more time. What was that? Say that one more time. So this kind of sentences, whatever you want, you can add it here. You can save this one. And on the basis of that, the bot will be able to tell you. Now the main thing, right? Quickly, like we have still like couple of minutes. So try to understand that what we are trying to achieve over here. What I have to do is, now I have to tell the bot, right? Tell me the weather. And on the basis of that, it should be able to give me the weather, right? That is the first and foremost thing trying to understand there. For that purpose, what I have to do is I have to create one intent again. So that intent will be called as weather. And for that purpose, I have given just W. And in this weather, we can now configure. Okay. Similarly, like training phases and the response phases, right? Whenever it asks the about the weather, what could be we have to guess like what could be the probable questions if the human can ask, right? So we can list down them. Let's try to understand. I will not go into further detail, but at least I have to try to show you this one. So tomorrow we can start with the integration and try to look at the other API part, complex part. So let's try and understand that. If I want to know about the weather, at first I have to create that intent, right? Because my user or whatever human is trying to understand that what is the weather. So for that purpose, you can give any name. In this case, I have given W, you can give weather also. And then you have to give again the training phases. That tell me about the weather. What is weather? Tell me weather. What is weather? Anything. How is weather today, right? So any kind of question, whatever comes to your mind, right? You can add over here. So do I need to keep on adding all the list? No. So what it will do is you have to give some general, let's say inputs. On the basis of the inputs in the background, it will try to understand the sentiment also by its own. So that will try to look into detail, but try to understand. So I am writing here, right? This kind of thing. So it will get added. On the basis of that, I have to generate the response, right? Good weather, nice weather, cloudy weather. So let's try to test this one, how it performs. Now I will say, tell me weather. So now it's saying, please enter the city. That I have done adjustment. That's why it's saying, but I'll remove that adjustment and try to save. And you'll try to understand how to create the response. Just a quick 1 minute, guys. I know it's almost time. I'll just show you this working, weather working. Then we'll be able to close this session today. Let's try to understand again. How is weather today? So it's saying good weather, right? It's saying good weather. Why? Because I have given this kind of responses. Again, try to ask the same thing. It will give you a different option. It's raining today, right? Because we give this kind of option, raining today, cloudy today, this kind of thing, right? But what is our use case? We need to get a exact, right? Exact temperature, exact weather. For that purpose, we have to expose the API, right? And for that purpose, we'll be using open weather map, right? So we'll try to go and deep dive into these things, guys, tomorrow. I think this was a good session for the beginning. And then we'll try to understand, go in detail, like how to expose the API, how to create this API quickly, and then how to expose this API into Google Dialogflow, and then how it will be able to give us the exact weather and everything. We'll try to test this also API. Hope guys, you guys enjoyed this session because we had a very heavy session. We created this artificial neural network for multi-class classification, and then we started with a very interesting topic of the NLP. In the NLP, we are trying to create a simple chatbot which will be able to understand the human language. On the basis of the human language, it will give you a reply. Okay. Hope you guys enjoyed this session, and just give me your feedback, guys. Any other feedbacks? So we can again tomorrow start with the complex topics, right? How to integrate APIs, how to integrate different services, how the chatbot will be operational, and everything we'll try to understand, and we'll try to start with the convolution neural network, which is again a very interesting topic. All right, guys. So we can say thank you very much, guys, then, and see you tomorrow then. Okay. If you have any questions for 1 or 2 minutes, maybe I will try to stay back and give you answers. And whosoever would like to leave, they are more than welcome. And let's come back tomorrow and try to work on this one. Okay. So we'll create a bot, and you can use this bot, okay, for whatever purpose you want. You can work this and then your personal assistant. It will make a homework for you. It will try to create a notes for you. Everything is possible. All right, guys. On this note, I would like to close this session today. And thank you very much, and see you tomorrow then. If anyone having any query, just ping me for couple of more minutes. I will stay back. All right, guys. Thank you very much for your positive feedbacks. They should give us a chatbot free. Yeah, guys. Chatbot, they will try to give you free, but what they will say you is just give me the services charges, right? To use the cloud. Chatbot, they will give you a free product. That's not a problem for them. But what they will say is use my products. Like, let's say in this case, the Google Cloud. They will say you use my Google Cloud, and I will give you a chatbot free. Previously, guys, these services were very costly, but at least now, as the rise of AI, they are able to charge you on the basis of the only transactions. So that is the best part now they are offering. Okay. And anyhow, as an individual, we are not going to use these chatbots, right? Whenever we will go to corporates also, they have a good budget, so they can manage this thing. So you don't have to pay for this. All right, guys. Anyone else want to ask anything? Any doubts? Please share today attendance link. Guys, it's already shared by Amar. Amar, can you please share it once again? Yeah. Amar has recently shared it, guys. So you can refer to that one. Just share this in the comment chat box. Guys, anyone would like to ask anything? For a couple of more minutes, then I will try to leave this meeting. Any doubts or anything? Any feedback? Quickly, guys. We have a couple of minutes only. I will wait for 1 more minute. If you guys don't have any question, then I will try to leave this meeting. All right. Anyone else? Any doubts? Any feedbacks, guys? Quickly, guys. We're still waiting. Quickly ping me. Otherwise, I will assume that you guys don't have any other questions. I'll try to close this meeting then immediately. We're already 6 minutes late. All right. Okay, guys. I will assume that you guys don't have any further question. So, all right then. Thank you very much once again, and then see you tomorrow to continue with our chat bot. All right. So, Amar.